Let us look at envelope of a family of curves. Okay, so let's look at the definition first. The envelope of a family of curves is a curve that is tangent to each member of the family at some point. Not very helpful, right? So let's look at this with an example. Let's take a circle. Okay, so we are given a circle x square plus y square equal to r square, where radius r, we are going to keep it as a constant. Now, let's take another circle of the same radius and we keep changing the y position. So, x coordinate remains constant, y coordinate keeps changing. So, something like this. X square plus y minus alpha square is equal to r square. Now, this we call it as a set or family of circles with centers at 0, alpha. Naturally, which means we can also have a family of circles with center at alpha, 0. So, which means something like this. So, this is another family of circles. Let's take this one, this family of circles. What we want to know is the curve which is tangent to all these circles in the family. So here remember, in both cases, alpha is a parameter. So as we keep changing the parameter, we get the different members of the family. Now, as I said, let's take this. This can be written as a function of x, y, and alpha. So f alpha is equal to x square plus y minus alpha square minus r square is equal to 0. So we bring r square to this side. Now, since alpha is changing, we do a partial derivation. So we find the partial derivative of f with respect to alpha. That means except alpha, everything we treat it as a constant. So dou f by dou alpha is equal to, remember this is a constant, so 0 plus 2 times y minus alpha times minus 1. Again, r will be constant, so 0 is equal to 0. Let's start simplifying this. 2 times y minus alpha times minus 1 equal to 0, which means minus y plus alpha equal to 0, which means y is equal to alpha. So what we do now is we substitute y in our equation or function with alpha. So what happens? We get x square plus alpha minus alpha square minus r square equal to 0. And if we simplify this, we get x square plus 0 minus r square equal to 0, which means x square is equal to r square, which means x equal to plus or minus square root of r square, which means x equal to plus or minus r. So that means this and this are the envelope of this family of circles. Similarly, we can do it with respect to the family of circles defined by this. Let us look at the next example. Let's say we have a family of parabola. Now, what will be the envelope of this? So we know this straight line, that is the x-axis, will be the envelope. Why? Because that is the only line which is tangent to all these parabola. So let's see how we can arrive at this. We know x-axis will be what? Y equal to 0. So we have this parabola or family of parabolas, y is equal to x minus alpha the whole square. We convert this into a function. G of alpha is equal to y minus x minus alpha the whole square is equal to 0. And we do a partial derivative. So dou g by dou alpha is equal to 0 minus 2 times x minus alpha times minus 1 equal to 0. And now we start simplifying it. 2x minus 2 alpha equal to 0. Be careful about this. Minus 1. So which means x equal to alpha. When we substitute it back, we get y is equal to x gets substituted with alpha minus alpha square, which means y is equal to 0. And that means this is our envelope for this family of parabolas. Let's look at another example. Let's take a family of lines, straight lines, right? That would be interesting, right? So this is a family of lines. We want to figure out what is that curve which is tangent to all these lines at some point on it. So let's do that. So here y is equal to alpha times x plus alpha. This is the family of these lines. Convert this into a function. H of x equal to y minus alpha x minus alpha square equal to 0. This minus minus comes because we bring it to this side. Okay. So again, partial derivative. Dou h by dou alpha is equal to 0 minus x minus 2 alpha is equal to 0. Simplify this. We get minus x minus 2 alpha equal to 0. Alpha is equal to minus x by 2. Substitute it back. Y is equal to minus x by 2 times x plus minus x by 2. And simplify this, we get x square by 4. Immediately, the moment you see y is equal to x square by 4, you should realize that it is going to be a parabola. This is the curve which is tangent to all these lines at some point. Let's look at a final example. Let's take a circle. X square plus y square is equal to r square. And we take a point on that, A. And we take another point on that, which is a moving point. We can move it around the circumference. And now we take a circle which passes through both A and B. Now, of course, at this point, A and B both are at the same location. So the circle would be more of a point. But now let's start moving B. So we have got a circle which is passing from passing through both a fixed point and another point on the circumference. Okay. Now what we have to figure out is we have to figure out what is that curve which is tangent to all these circles at some point. Now, so we are given a circle. We have taken a fixed point A as A comma 0, taking a moving point B on the circumference of the circle, draw circles passing through A and B as B moves along the circumference. So the family of circles that we have arrived at is this. And if we go through the same process again by taking the partial derivative with respect to theta and arriving at the substitutions and carrying out the substitutions and simplifying it, we get the envelope of the family of circles in Cartesian coordinate form as x minus a square plus y square plus a times x minus a the whole square is equal to a square times x minus a square plus y square. And if we plot this, we get this. So if you notice that this curve is tangent to each of the circles in the family at some point. This shape is called the cardioid. Interesting, right? So that was envelope of a family of curves. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now. Bye.